Well, so it seems like there is a path out, but no one's really going there yet. Fortunately, you are, and eventually, necessity is the mother of all invention, and we're going to run out of power. We're going to have to do
No, we already are out of power.
yeah.
I mean, Microsoft's trying to invest in nuclear fusion. Google is trying to do the same thing. They're thinking about investing in solar. So everyone is trying to get more power because they're all power constrained every
Yeah.
year.
Welcome to Practical AI, everybody. My name's Jeff. I'm with Peter Lynn. We are in our second season discussing topics that hopefully are of interest. We are sponsored today by Pocket AI. Pocket AI is a tool used to perform surgery on your models to make them better. While everyone today is talking about RAG and refinement, Pocket AI allows you to edit the weights of your model directly. Peter, there was an article that came out. I'm going to share my screen really quickly, just so we can get this up. It was about power usage. And I think the article's headline said a lot. Yeah. North America added a whole Silicon Valley's worth of data center inventory this year.
That's
We've already talked that at some point, I think by 2030, power or AI will make up almost 10% of all of the USA's power usage.
yep.
This seems like a problem, something that needs to get addressed. What's your read on this situation?
I think this is just the tip of the iceberg because everyone is trying to build bigger data centers. Microsoft, Apple, Google, Meta are all wrapping up their capital expenditures, their CapEx, and they're all gonna put even more money into hardware. So as bad as this looks, it's probably gonna get worse in the next year or two.
Yeah, and meanwhile, I mean, this graph is out there too. The vacancy rates in these data centers are pretty low. So power is being consumed. There's not a lot of room in these data centers to play around with, right? So now this just smells, and like you were saying, like they're just going to be building more data centers. They have to. The
They are. Yeah.
capacity is there, right?
Yep. Yep. Yeah, and it used to be back in 2000 when I was building a mobile platform, we went to level 3 to get hosting space. And it took us 6 months to get the actual rack space. And then it took us another 3 months to actually install the hardware and get it all set up. Um, that's like peanuts compared to what AI data centers are. AI data centers have anywhere from 10 to 100,000 GPUs, and each one of those is probably in a DGX rack, which takes a maximum of 8. So you do the math, and you've got tens of thousands of DGX racks you got to install and set up. So, and that takes time. I mean, people have figured out how to do it quickly, but it still takes time.
So maybe just stepping back a little bit. Obviously, the AI um, the AI thing, broadly speaking, has sort of accelerated this data center and energy um, gap problem, whatever you want to call it. If we look at growth of data centers and energy consumption as a problem, AI has accelerated that, right? It's
Yep.
it's had a big role, and it's turned it from you know, it's made it hyperbolic on the scale, right? So, but as a general layman in this space, I kind of think of it like, okay, training. Training the model, yeah, that should consume a lot of power, right? Once I'm in run, do I have to use as much power as I'm in training?
Today you have to because the models are huge.
It's no benefit to be in run mode. It's
Well, I mean, so when you're running, so let's say when you're training, you spend up between 10 and 20, 30,000 GPUs. Okay, so that's all fine and good, and it runs for 6 months to train the base model, and then another 6 months to the refinement. So basically 8 to 12 months of just training. And then you guys spend another 3 to 6 months to do validation. Okay, so broadly speaking, a year and a half. But that's just the system training on its own. Once you get 10 million people using it, that's more load than training because you just got a massive number of people that all want to load the same model and use it. And so when you ask GPT something, it takes it seconds to process. So you just gotta do the math of like, okay, if I got 20 million people using ChatGPT and it takes 5 seconds to process one prompt, you just do the math.
yeah. Okay, so is one of the problems that we have that um the current AI method is people really aren't building their own models. They're essentially cutting and pasting from Anthropic or ChatGPT or whatever, right? They're essentially piggybacking off of the
Data.
LLMs that are created. There's these huge monoliths. So when a big company like, I don't know, Target stores or JP Morgan or whatever, when they want to do something in this space, they're not building their own model. They're essentially starting with doing this big transfer learning exercise with OpenAI's platform, right? And they carve out their own section. And so they've basically copied multiple times this huge billion parameter or billions parameter model, right? And that's part of the load on the systems, right?
Well, it's worse than that. So if you're Target or your Best Buy or Walmart, and let's say you want to build a customer service system using GPT-4. So great. You create a data set, you upload it to OpenAI, you let it train, refine, and 12 months later, you have one that you think is good enough. Well, so now you've got this trillion parameter model, it's got to load up. And if you've got a peak of, let's say, 10,000 customer support, either through the web or through the phone, right? You need probably half that number of models running. So you need 5,000.
Yeah. Okay.
Right. There's going to be ebb and flow. It's going to peak probably around noon time and around 6 and 7 p.m. And the rest of the time it'll probably be pretty low. But you have to handle the peaks.
Yeah, now we're back to like the Amazon, the original Amazon's, Christmas time problem, right?
Prime problem, Amazon Prime.
Yeah.
Yep.
Okay.
Everything.
So in your world, what you're working on, the solution you've done with your edit method and Pocket AI is kind of the opposite, where you're not starting with an existing model. You're building your own models and you're intentionally trying to keep them smaller. But as a potential user of this type of solution, um, I would be concerned that can your model handle everything that a Walmart or whatever would want it to do? And if not, how are you solutioning around that? Or what's the solution of using smaller models that don't do everything? So I guess what I'm asking is, how do we get away from these monoliths and get into a different model where it's a smaller model?
Well, so the first thing is, even if you were to use, let's say, Llama or Claude or OpenAI, there's a kind of dirty little secret, which is all those models are over parameterized, meaning it does a lot more than you actually need because Llama 3 is trained on a trillion tokens. If you're a target and you just want to answer questions about like, hey, I'm looking for a cooler, what's the best one? you don't need 1 trillion tokens. And
Okay.
there's probably more than half those tokens are completely useless to you.
Well, half the tokens are useless, but also within the model itself, over half the weights are probably
More than
useless.
half the weights are useless because it's dealing with things like Python or programming languages or like some other thing that you'll never be asked.
Yeah.
But the downside is once you've built your model on a GPT-4, all those weights cause these weird side effects that you can't control. Right. So if you could prune all those weights that cause noise, it would make it much harder to jailbreak.
Okay. So you get a jailbreak benefit, you get an energy benefit, you get a training benefit.
Training, not as much, but once you deploy it, your model could be a third or a quarter the size.
Okay, well, it's less likely to hallucinate then too, right? Because it doesn't have the noise of the useless or the unused parameters, the unused weights
Yeah.
that could kind of go sideways on you.
Right, because if someone does the padding method of jailbreaking, right, it's just gonna ignore it because those tokens are gone.
And then in your world too, uh, you could go ultra small, micro with the models and daisy chain a bunch of smaller models together, right? So explain that just really, really briefly.
Right. So you start out with a model that's decent, and then you refine it on just a super narrow set of tasks. And then because of that, we can identify what weights are involved in that specific thing. And you can trim all the other weights. So now you've got the super tiny, super focused model that is just like the thing you want and nothing else. And so now you can chain together all these smaller models. And the benefit is you don't need to run it on a DGX. You can run it on just like much cheaper GPUs.
Yeah,
And
maybe
so,
someday just on your iPhone, right?
yep, yeah, eventually.
Well, so it seems like there is a path out, but no one's really going there yet. Fortunately, you are, and eventually, necessity is the mother of all invention, and we're going to run out of power. We're going to have to do
No, we already are out of power.
this. Yeah.
I mean, Microsoft's trying to invest in nuclear fusion. Google is trying to do the same thing. They're thinking about investing in solar. So everyone is trying to get more power because they're all power constrained. Every
Yeah.
year, business says every data center is power constrained. So we're already out of power. That's we're already there.
Yeah. Well, let's do it. Let's make these models smaller and let's get away from the monoliths. Peter, this is a good discussion. I'm sure we're going to do this a lot more, this particular discussion, because this ain't going away, this problem. Thanks, everybody. Be sure to follow, like, and subscribe and ask us any questions. We'll try to address them. Take care.